This is the Amp Hour Podcast. Released January 23rd, 2022. Episode 574. Bubblegum Tap Shoes.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
2022.
Well, we said that last time you were here, too.
Oh, did we? Oh, okay.
Yeah, that was our New Year's.
Yeah, but we
Remember,
actually
we were
shot
recording
it.
in 2021.
But I know, it's actually really 2022, and it's really depressing. Yep.
Yeah, I'm sure the summer is very depressing in Australia.
Right. I did actually tweet this out once 2022 came around. 2022 is the year of Soylent Green. That Soylent Green happens. So, warning.
You know, if Soylent Green ever does come around, you know that there's going to be like a bunch of influencers that are all into it.
Right. Well, Soylent was a thing like a decade ago.
Soylent, the
drink.
Supplement, yes.
The supplement, yes.
Yes. I believe we've mentioned that on the show before, and really just how terrible a name it is, but we are talking about it, so.
Exactly. And it's just died away. I haven't heard of it since.
I haven't either. You know, I was into it. I think that's probably one of the reasons
really?
we were talking about it.
You're right.
I was into it. I was into it. They had a flavor. It was like coffee, and it was like mocha, and so it was like coffee flavor and chocolate flavor. And then I thought about it. I was like, I can just mix chocolate protein powder into coffee in the morning. And I was like, saved 80%. So
save having to, right.
Yeah. And then I got sick of it, as we do.
Don't do it, because then you'll end up with soy face.
Soy face. There you go.
Soy face, as they call it. Yep. All right. What do we got?
Well, you just came back from holiday. How was that?
Not too bad. I was not well over the break. But
oh, no.
I'm better now.
COVID?
So
COVID?
no.
Did you catch the Ovid?
Well, may have. I don't know. Who knows?
It is extremely prominent. Prominent? It's very common around
I know
here.
what
everybody's
trying to use.
Everybody's catching it, Dave.
Everyone's got it. It's really trendy.
Yeah.
Right.
Luckily, not everyone I know is, vaxxed and boosted and having just like a bad cold version of it. So I'm very grateful for that. But yeah, it is everywhere in the States. So coming soon to a locale near you, I'm sure. Hello, Omicron.
Did I ever tell you about the story of when I turned, let's just say 30?
Sure, yeah. Folks, he's no spring chicken.
Yeah, exactly. So, I got, I'm doing the thing. Oh, yeah, I'm about to turn 30. And, I'm so old, I'm going to have a heart attack. Sure enough, I wake up on my birthday. I am not kidding, in a cold, in a sweat, and I'm hunched over and with chest pains. I'm not kidding.
You psychosomatic yourself into it, huh?
I think I might have psychosomatic. But no, we raced to the, it wasn't I sort of tried to stretch all myself out and everything, and I thought it might have been like a workout. I just, did too hard in chest or something, Yeah,
but, maybe, the spicy buffalo wings or something like that, the night before,
Yeah, but it felt really bad.
Flux.
Right. So anyway, it wasn't bad enough hospital. So I thought, I got to go to the doctor. This is So I go to the doctor and, I walk in and, tell him the symptoms and everything. And he's going, he's just, shaking his head. And I'm going to, I think I've got might have a heart issue. And I'm going, are you at least going to check my heart? And he goes, no need to. I know exactly what it is. And no, it's because he had already seen 5 cases in the last couple of days. It was a virus that infects your chest muscles.
Oh, interesting.
That causes them to spasm and stuff. It was a virus going around. He said, I've seen a whole bunch of them. Yeah, that's what it was. So, whoosh, it was just it's just a viral infection. But
I guess so. But
a heart attack.
Much like when walking into a troubleshooting session and an engineer like Dave says, I know what the problem is, you do want to still do a test. You want to confirm somehow.
Assumption is the mother of all you-know-whats,
Yeah.
Assumption. So,
Yep.
Ah, boy.
Well, I'm glad you're okay. But sorry, your holiday wasn't as relaxing as you'd like.
No,
But
no,
now
it
back
was
to the
still
world of electronics. What's more relaxing than that?
exactly. Well,
Yeah.
can we get into some mystery?
Mystery,
Electronics
intrigue,
mystery, intrigue.
spiciness.
Although I
Yes.
think I know the answer, but I think it's more. I think it might have morphed over the years.
Okay. No, you posited on Twitter, I believe.
I did posit on Twitter and also in my recent video just released this morning.
Okay.
Which I should have actually Googled it. I should have actually done some research before I actually put it in my video, I guess.
Whoa.
Anyway, so I think I know the reason, but it doesn't mean it's the reason these days. 1N4007 diodes, right?
Yep.
I'll send you a link to I've got a PDF, right? There's 10 million different manufacturers of 1N4007s, right? Or the 1N4.
Yeah, I don't know if this is maybe the definition of a commoditized component, if not.
Yes, this is a jelly bean power diode. If it's the jelly bean power diode, right? It's been used since time immortal, right?
Yeah. Back when Dave was 30.
Yeah, right. And anyway, it's the 1N4000 series. So you got the 1N4001, the 4002, the 4003, the 4004, 4005, 4006, and 4007. Oh, goodness. And the only difference, have a look at the first page of the data sheet that I just sent you.
Okay. I'm looking.
What is the difference between them?
Well, the first page is maximum ratings.
Don't worry about maximum ratings. Yep.
What else is different?
Oh, sorry. Yes. The actual, yes. Take a look at the maximum ratings, but also
I guess the maximum ratings are also the VRRM is so that's the repetitive. Is that the repetitive reverse maximum voltage?
Peak repetitive maximum reverse.
So basically,
they
you're
often
slamming
don't
this thing
put peak in there.
in so if you got it in a bridge configuration and you've got very, very big sine waves coming in.
Yep.
Okay.
So the only difference is the voltage.
It's the voltage,
right?
Yeah.
Nothing else is different. So why? My question is, why do they bother even making a 1N4001, which is a 50 volt nominal DC rating? Let's just work with DC, and the 1N4007, which is 1,000 volts, and then they've got 50, 100, 200, 400, 600, 800, and 1,000 volt ratings. Why do they even bother manufacturing?
Default to 1,000. You're saying?
Yeah,
that's what I'm hearing.
Why don't they just make 1N4007s? And this came about because in my latest video, I took apart my BM235 multimeter because a customer was having a problem with leakage. Sorry, not with draining of the battery, even when it was in the off position. Right?
As we age past 30, there's also leakage problems. So
there's also leakage problems. not at my end. Anyway, I'm not that old yet. So there's
we're all headed that way, Dave.
It'll be the puns will start if that ever happens. Yeah, I'll be on Twitter or whatever is being used for Twitter at the time, and I'll be right. Just Anyway, yes, my first
BM235.
BM235. If it's draining the battery in the off position, it means there's some component across the battery. Right, when like actually before the physical switch, the physical rotary switch. And of course, the classic is the reverse protection diode for the batteries, right? And sure enough, I open it up and there's a 1N4007 in there, right? And of course, it's obvious why they use the one in like the 1,000 volt rated one across the battery, because they use it elsewhere in the circuit, especially across the users on the current ranges. I've got a video on that, by the way. We should link it in, how multimeter input protection works with fuses and actual diode bridge protection and stuff like that. Anyway, so they obviously want to reuse that part. If you don't want to have a reel of components on your pick and place machine for the 1N4001s just for the battery, and you've got one of those and you've got 4007s everywhere else, that's just dumb. Right, so they simply reuse the 1N4007, and then it just occurred to me, why would you even bother buying a 1N4001? And I asked on Twitter, has anyone ever legitimately used for electrical reasons, not for cost or some other reason, electrical
because it's
reasons,
the only thing available in 2022.
Yeah, exactly. Have they ever used a lower voltage part for electrical reasons instead of the high voltage part? And then, sure enough, somebody on Twitter replied that, it's the it could be the doping the 1N4007s have different doping to the 1N4001. And then that kind of rung a bell. I kind of have a vague recollection of that being the case. And sure enough, I found, here we go. I will post it to you. Oh, can you post images in the stupid? Yep. There we go. You've got it. There you go. I found this old Motorola data book, which shows two curves for the 1N4001 through to the 1N4005, and then another curve for the 1N4006 and 4007. So it seems at some point in the past that there were two variants, not like 7 as the data sheet shows. Sure. There were only two variants, and maybe then they selected on tested like those ones to get the 1,000-volt bin in or something like that, perhaps. And they had different junction capacitances, and they had different reverse recovery times. So it might be a speed thing.
Right. So that's your trade-off there.
But on modern data sheets, I can't find this. Granted, I haven't looked at 100 data sheets, which I'm sure there are. I've looked at like half a dozen, and I can't find it, right? I can't find any mention of this anymore. So
interesting.
Does anyone definitively know in modern times if there's any difference between them? Because the package is the same, right? It comes in a little surface mount SMB package for the 1,000-volt one as it does for the 50-volt one. So it's not that.
Well, I went to my favorite just now. Like, this is not extensive, but my favorite resource for all things schematics, which is Google image search, and I would just search for what has 1N4001 in it instead of 4007, and there's other stuff in here, but it is all just like low voltage, and it's very, at least the schematics here.
You would put it on a secondary side of a transformer.
That's right. Yeah, like a 12-volt output or something like that. A 12-volt output
instead of a primary side.
AC to DC converter type of thing. Yeah. But that doesn't really lend itself to, I need speed. That's more, I think, probably, this was available at the time. This isn't really a precision part ever, though, either, right? It's not like a small signal model. It's all very chunky.
Yeah, it's chunky, and you get what you get, and you don't get upset. It's like,
right.
Yep.
So, so I think I agree with the basis of the question, which is why bother having all these other things? I guess maybe not 4001, but maybe the 4 or the 6, right?
The 4004. Like I've always because way back when I was a boy, 4007s were kind of like special. The 4004 was the one you would use all the time because it was it was the 400-volt rated one, so it could do mains and stuff like that. And it just it just actually did the business, right? For almost everything you used it for. There was no reason to go to a 4007. Unless you were using doing 3-phase mains rectification or something, like some sort of, more obscure thing that the average hobbyist engineer wasn't actually working with, unless you're into the power field or something. So
now here's a question for you. So back in the day, this Motorola, thing you sent me, and I'll try and post the image in our notes as well. But back in the day, would there have been more spread? So everything's gotten so commoditized and so pushed down. Would there have been a much higher spread, or especially at the high end for an 07 to be, so now if you're going to put 10 of these in a product, that it, if it goes from 1 cent each to, so a 4001 is 1 cent, and a 4007 is 7 cents. And so that difference of 6 cents on a single one times 10 parts in design, that 60-cent difference might actually be worth it. Whereas these days it's all so cheap. Anyways,
exactly.
You know what I mean? Just like over time, everything kind of gets squished down towards effectively nothing, but in high enough volume stuff, maybe it does matter.
Yeah.
Maybe you're saving money.
I don't know. But there might be a price difference, but I'm asking why? Because surely they aren't doing 7 different process differences for 7 different diodes in this range, right? That just seems ridiculous. So I'm kind of, erring towards the old Motorola data sheet where there were only ever 2 types of diode.
Yeah, and that could be. And it could be they're just binned in between or something
and they're just binned or whatever. But you would think that these days, because the process technologies are so good and so consistent and everything else, that you just wouldn't bother. Make it it's they're maybe they're all 1N4004s, for example, if they're making like the lower volt, but they just mark them 4001 because some people have them in their bombs.
In
maybe
a part. Yeah, that's right. Yeah. And a military contractor is not changing their part number for anything.
No, exactly.
Let me tell you.
yeah. That's it.
Yeah, that could be. It could be. I wonder what the fab is like too. You think about like, so there are probably some just size minimums just for voltage spacings and stuff like that. But even still, like, it's probably a pretty small piece of silicon in there.
It is.
Then,
I mean, I said, it's an identical surface mount package for the 4007 as for the 4001.
Mm-hmm. Yeah.
1,000 volts versus 50 volts. That's just nuts.
So what does these wafers look like? They must just be like
I don't know. I would have to crack one open. You'd have to sand one open or something. But yeah, I almost doubt whether you can. The one I found in my BM235 multimeter, it's a 4007 part. It's 1,000 volts, but it's in an SMB package. Can you even get 1,000 volt rated part in such a small-ish package? I guess technically there's clearance there. I guess it depends how long the leads are folded under, I guess. But boy, and how close the pads are together, and if you've got an isolation slot. But if you were serious, you'd put an isolation slot under them, which you will actually see if you take over like a light switch mode power supply ceiling light or something like that. One of those. Even the cheapies, they will go to this effort. They will actually put isolation slots under the surface mount diodes because, like they're directly rectifying mains, right? So it's pretty high voltage stuff. Yeah. And any leakage on the board is going to be a problem. So
higher there than here, Dave. Higher there than here.
Oh, yes, higher here over there. Although you guys are 240 volts.
Yes, we've mentioned that.
America is 240 volts. But, yep, you guys just do something weird in the box to make it 120. I don't know. Yanks. Yeah. Yanks. Anyway, so, you'd put isolation slots under them, especially on the surface mount parts, But anyway, does anyone know definitively, whether or not these days it's exactly the same die and they just don't bother? Because the specs are the same. The capacitance is the same. Like, there's no junction capacitance difference. There's no leakage current difference. There's no forward voltage difference, which I believe there used to be a forward voltage difference between the 4001 and 4 and the one in 4007. So nowadays the data sheets are identical. So I can only assume that the silicon's identical.
I mean, looking at the schematics too. So I was just searching on 04, 05, 06, 07. Well, I skipped 07, but just like all the in betweens. I guess I did 03, 05, 06, right? So like non-common type of stuff. It's all, just really old data sheets, and it's all in the same, it's all bridge configuration,
right,
coming off a transformer. It's all the exact same thing. So I have to imagine this is a pricing difference from back in the day. That's got to be it.
Right. And they've just stuck around because people need them in their bombs.
Yeah.
Speaking of which, this would be a good example for multiple bomb items, because if you're designing a product and you want to make sure you've got availability, then back when I was working on the military stuff, we would always have to make sure we had 3 different vendors and 3 different available parts that were qualified to go into the product, so that we can actually swap them out if we needed to, right?
Yeah.
In this case, let's say you got a main switcher or something, you would go, okay, well, I can use the 4004, the 4005, the 4006, and 4007. So you'd have all of those in your bomb. So at any point, you could use, you can substitute in any of those and it'll work. Right. So, yeah.
And that is a good example too, because usually it's, you might have like a base number. So like an LM317, and then it's got some other package codes or packaging types around it. And you're like, oh, well, all of these are the same part. But when you actually change the base number, a buyer's going to be like, well, that doesn't look the same. And so you have to specifically call that out and be like, no, this is an effective replacement.
Right.
And so,
yes.
Yeah. And then you have an internal part number.
I can remember getting so many phone calls from the purchasing department going, Dave, can we substitute? We can't get this part. Can we substitute this? It's got one difference in the letter. It's like 10 letters long, and it's got one.
We can't get a resistor. Can we switch in a transistor?
Yeah,
it ends in ister.
Right.
Could we call your sister and ask her?
Oh boy. Yep. The purchasing people eventually got like really good. They could actually, even though they didn't really know electronics, they actually got to a point where they did know that, oh yeah, this is a ROS compliant letter in the number and stuff, you know, in the part number and stuff like that.
I mean,
you know,
my best friend is a purchasing agent, so
Yep.
I'm not allowed to disparage them. And also, I
Right.
had some very good purchasing agents in the past.
Yep.
Actually, I regularly disparage him, but I
Right.
shan't
Okay.
here. You know, just the usual.
Yeah, of course.
good
Yeah, the
friend
usual.
stuff.
Yeah.
But yeah, no, I mean, yeah, I think that it's just familiarity over time too. They're
Oh
not
yeah, of
gonna
course.
they're not gonna help you debug a circuit, but yeah,
No.
they're gonna definitely know the node differences over time. It's
Yep.
just I think the ramp up can be tough, especially like new programs. I think like when you go through an NPI process or new product introduction, it's always tough because it's like this is stuff that you as a design engineer you've been working on it, you've been trying out all these different things, and it looks you have all this familiarity, but until it's been in production for a couple months, couple years, whatever,
you don't. Yeah, you can't
and
be 100% sure. Yep.
that's right. And then
Yep.
and then the purchasing agents kind of get a feel for it too, and then it should hopefully be on autopilot if all goes well, unless it's the past 2 years.
Yep.
So.
And I may or may not have skipped qualification because I was absolutely confident in that part would work. I can never confirm nor deny that I
that's on you, man. Yeah.
I use my engineering judgment to go, yeah, that doesn't matter a rat's ass, you know. So yep, qualified, you know, tick.
I mean,
Right.
that's great. That works great until it doesn't.
Right, yeah, exactly.
Oh,
But
boy.
that never come back to, I can't recall that ever coming back to haunt me. So my engineering judgment must have been good enough.
It's still there, Dave. It's still lurking.
Right.
They're gonna call you.
Yeah.
They're gonna call you in about 10 years.
Right, in about 10 years.
Yeah.
Have you ever been called up from an old job? Has an old job ever called you up and asked you to ask you a question or to fix something because you're the only one who knew that thing?
No, I was never that important.
No,
I mean,
okay, right.
Yeah. I
Yep.
assume for you they had.
Oh
though?
yeah, because I was the one man band often in companies I've worked at. So it was once I left, you know, so I tried to document everything, but there were tons of stuff. It's like, you know, you get phone calls and do you remember how this line of code in this production test jig, what this was doing? Oh yeah, I remember that, you know, so I'd give them a free.
Really? Oh wow.
But,
I don't.
Yep. But I would draw the line of going back in there and actually troubleshooting. That would
travel
cost
time.
them.
Travel time is going to cost you.
That'll cost them a phone call's free. I'll do that for nothing. But yeah, yep. Oh boy. No, so you weren't that important, huh? That's sad.
Never have been, never will be, Dave. It's important to stay humble, especially.
Right, okay.
And on the electronic side of things, it's very easy. In fact, I was very humble this past week as I was working with a student, and he asked me a question about an LM317, and I was like, I know how this works. Let's open your books to section 9.3 of the Art of Electronics, and I start reading it, and I'm like, I have no idea how the LM317 works.
Well, to be fair, unless you look into the details, it's not something you'd probably learn. You'd formally learn.
Yeah.
It's not.
You know what I think it was? I think it's because I can with my eyes closed, I could draw an LM317 in terms of like a block. I got the in, I've got the out, I got the feedback resistor, I got the adjust pin.
Oh, okay.
I know that 1.25 volts is very important here.
But
and
you wouldn't be able to draw the internals though.
Oh, definitely not the internals.
Oh, okay.
And apparently, definitely not the control equation either, which I thought I had down, but I do not.
Yeah, but surely you've looked at enough data sheets that have the internal diagram to just get a feel for it over time. Surely you've looked at.
Oh, get a feel for it, sure. And I know how a regulator works in in this abstract way. Yeah. But what I'm saying is I was like, oh, I know that it's got a 1.25 volt reference. You use a 1.25 volt reference. So I was like, okay, so we want the feedback node to be 1.25 volts.
Right.
Right? Wrong. That is wrong. I learned that. The feedback, because what it really was is I was trying to explain you can use the 317 as a current source.
Yes,
right? That was
you can. You tie the adjust pin to the output. Yeah, it's nice via a series resistor, and then the voltage drop, then the 1.25 reference voltage drop divided by the series resistor gives you your output current.
Right, but it's not because that's what was in my head is a 1.25 volts. I was like 1.25 volts, 1.25 volts. I know there's a 1.25 volt reference in here.
You're right.
But it's actually, so if you look internally then, there is a reference and then it's the difference. Man, I'm going to mess this up now too. You have to add the reference voltage 1.25 volts to the control voltage at the divider node, right? So if you've got the output is some unknown voltage, and then it goes down through a voltage divider.
Yes.
2 resistors in a series, and then in between there, that's the control node. And I was like, that has to be 1.25 volts, but no, it's not that. It's
the 1.25 volts is across the upper resistor. It's across the upper divider resistor, not the bottom divider resistor. Yeah.
That's where my whole mental model was broken.
Right,
but it has been rectified. So yeah.
Okay.
Very good. So then like looking through it, and it's really interesting too. Like, so I didn't realize. So like, obviously, like I said, section 9.3 of the good book known as The Art of Electronics has a detailed explanation about this.
Oh, okay, excellent.
But seeing it drawn in different ways as well, I felt like let's see, what's my favorite
just
one?
drawing something, and this is true in all of electronics. Just drawing something in a different way makes the world of difference. Like drawing your schematic in a certain way, like. Don't draw your schematics like Bob Pease, by the way. Bob, like you cannot make heads or tails of Bob Pease. I assure you, he must have done that deliberately. He must have been deliberately. Was Bob Pease deliberately trolling everyone? He must have been, because nobody draws schematics like him, right? Go look at any Bob Pease schematic, and it's like a dog's breakfast. Stuff's going in and out and back and forth and up and down and criss and cross. It's unbelievable.
Yeah.
Bloody Bob. like absolute genius, right? You never doubt Bob Pease, right? Sure. But his schematics, holy crap. Yeah. I'll see if I got a good example. I'm going to have to call one up. Bob Pease schematic. Anyway, sorry for the non sequitur.
Yeah, I mean, so the real reason is like I started looking at like figure 9.13, if people are following along at home, is like an actual like transistor level diagram, and like you start to see structures you understand, right? There's a differential amplifier in there. There's a current source. There's so all these things that are like recognizable, but then it's really the simplified view is what I'm used to seeing. And so if you look at like then 9.11, I think.
Sorry, I don't have it open.
That's okay. 9.9 rather. That's the simplified view where it's like, oh, okay, that makes sense. It looks like a op amp with a feedback element. So you're driving you're with the output of the op amp, you're basically driving a transistor, and then there's a feedback controlled voltage, just like any other current source that's out there. It just looks like a current source with a reference compared there. And so, yeah, that made a lot more sense to me, but at the beginning it's like, yeah, okay.
Right.
So it's kind of just how you come into it as well. Oh wow, You were not kidding.
Yep.
Wow. I'm looking at Bob Pieces as well. This is
some funky. Yeah. You have to be smoking
although
something.
Bob Piece wasn't one of the designers. It was Bob Dobkin and the middle finger guy.
Come on. Don't. I have mental blocks.
Mm-hmm.
Oh, come on. No, this is embarrassing, Chris. This is just embarrassing.
Sorry. Weidler. Bob Weidler.
God.
Bob Weidler. Yeah.
Can we edit that bit out, please? That's embarrassing.
We'll try. Yeah. Yeah, so it was Weidler and Dobkin.
Yep. They were what?
They're the 317. They're the
they're the designers of the right.
Yeah.
Was it Weidler who did the 317 or was it Dobkin?
I don't
know. Anyway.
I don't know. I was reading it. I'm reading it in the good book.
Right. Yep.
I'm pretty sure. I'm pretty sure it said Dobkin and Weidler, but maybe not.
Okay. Right.
Doesn't matter.
Anyway. There you go.
I think it's very apparent that I should not have been the one designing this stuff. We would not have progressed as a species.
Right. Oh boy. Yep.
Yeah.
But anyway, so your challenge, Chris, is to understand Bob Pease's schematic.
Yeah. This, yeah.
I'm sure you could if you just sat down and thought it, but it's just like you can't just glance at any one of his schematics and go, oh yeah, right. that's how it works. It's just nuts.
Yeah.
Man.
Yeah.
He had a style, that's for sure. Anyway, I've done a video on that. Wait, what is that? The third or fourth time I've now mentioned I've done a video on that in this episode.
Third. That was the third time.
Okay. Yeah. Keeping track, are we?
You're talking about the linear versus linear and LDO and switch mode power supplies.
Oh no, I wasn't going to talk about that one, but thanks for bringing it up. Yeah,
There
I thought that was good.
4.
How there's technically, in a topology sense, no actual difference. And I'm sure I've mentioned this on the amp hour before. There's no actual difference between a switching regulator and a linear regulator. And if you don't believe me, watch my video, and I prove it.
Yeah, I mean,
well, you could say that it's entirely different topology, but the actual circuit is near identical, except that you have a little oscillator inside, and then you have a switch. I think what you're saying
is there's a voltage, there's like a feedback element in all of these things. There's a op amp and a feedback element.
It's the same feedback element. It's the same pass transistor. It's the same reference. It's the same everything, except the output, essentially the output of the op amp, the internal op amp, which is driving the pass transistor, that actually gets switched between a built-in oscillator and the regulation part of it. So it's, so it's actually, anyway, go and watch the video.
Go watch the video.
Oldie but a goodie.
Yeah, number 90. Back
in the garage.
Dave was 30.
Back in the garage.
Back before Dave was 30.
Yeah, right. Yeah. 21.
Yeah, I'm getting ready to. I've been thinking about your garage lab. I'm going to be putting hopefully a wood shop style workshop in the garage.
Oh, okay, right.
Very lucky to have my electronics lab upstairs, but
yep.
Yeah, the mechanical stuff might be happening in the garage.
Yeah, I've got to put them down in my dungeon here. My new dungeon. That's where I'm going to have a drill press and a whatnot.
Yeah. Yep. Yeah, it's nice to. I mean, yeah, when you need to have that, it's better not to
you can't. You can't have it in a lab. Like you can't have it in like an office electronics. Well, I could, but it's
let's be honest. I mean, the office and the electronics lab, that's for having solder splashed all over everything.
Exactly. Yes.
It's a different type of mess that we need, and then also
I don't often do the mechanical stuff, so it's like actually if I had an infinite amount of room in here, of course I'd set up a little mechanical bench that had a vise and a drill press and a grinder and the whole works, right? But no, not in the available space. It's just not worth it. So
Yep.
There you go. What else we got on the list?
Not on the list, but I've been learning. Not only am I trying to improve my, my knowledge of electronics, I've given up on Autodesk, and I am now completely open source. Dave, it's the year of the Linux desktop or laptop, as it was for me. I'm learning. I
still
FreeCAD.
don't run Linux. Sorry, I'm still running Windows. So meh.
That's okay. Yeah. So I've switched away from Fusion 360. I've officially made my first thing in FreeCAD.
Yep.
And let me tell you, if you thought KiCad's UI was funky, wait till you see FreeCAD.
Right. Well, I think you posted this on Twitter, and a lot of people said it's not worth your time. Just pay what is it, $50 a month for Fusion 360? How much is it? Monthly thing, isn't it?
It's I think $600 a year.
Oh, 600. Yeah. Man, there are people who are making the comment that it's just not worth your time.
Jay Carlson, past guest of the show.
Okay, right.
Respect Jay very, very strongly. He is someone who said, you should just pay the tax and it's worth it, for a tool that works.
Use the more friendly tool, right?
Yeah. I think that's, there's a argument for that. Jay's been very clear about that in Altium as well. And I think it's, from a consulting context, it makes a lot of sense.
Yeah, but Altium's expensive, right? Really expensive. So the argument could be made that, like 5 or 10 grand a year or something is a lot more than 500, right?
Yeah, I think the prices I've heard from Altium are like 5,000 the first time, 2,000 a year after that, 1,500 to 2,000 a year for like maintenance.
Oh, they want to suck you into the maintenance. Yeah, pipeline.
Yeah, exactly.
Of course they do.
That's what I've heard. So yeah, not a small amount of money by any stretch of the imagination. But even still, right? A couple so.
It comes down to what board you're doing. Like if you're just doing Raspberry Pi style, size and complexity boards, then it's meh. You don't need.
I mean, I'd say Raspberry Pi is pretty pretty advanced.
Oh
as
yeah,
a,
but
as a
I'm
board
you know,
itself.
I'm just like,
But maybe
you know,
a carrier
no
board for a
exotic.
Raspberry Pi.
Yeah.
4-layer, 2-layer, 6, and anything you might be sending to JLC.
No, but even then, just small
Yeah.
stuff, small scale kind of stuff. Even if it's 8 layers, you can still do it. It's more the size and complexity of the thing, really.
Maybe, yeah.
And,
I think a lot of that stuff you can do with KiCad is just you start to run into resistance as you start doing more and more.
Unintended.
You start to, it just as you're trying to do more and more high complexity stuff, like you're saying, you start to run into problems, and there's less tooling for it.
It's more to do with the efficiency of the tool and the user friendliness of the tool once you get into a certain complexity. I guarantee you can do any complexity board possible with KiCad, right?
Yeah.
Anything.
Sure.
But it's, but the but is the but part of it. It's like, no, if you're like, unless you've worked a month on a PCB layout, one layout, unless you've worked a month on it, you don't know what a complex board is, right?
Sure.
So
I do not know what a complex board is. That's for sure.
Right. Like I
mean, I have taken a month, but it's just because I'm kind of slow.
Right.
Yeah. No, you're right. And there's lots of different tools out there that fit a lot of different people. I'm not saying that KiCad or any other open source or even low cost tool is right for everyone.
Mm-hmm.
And I think at the end of the day, it doesn't. Whatever people choose, it's fine for them.
Oh yeah, no, it's fine. Yeah.
So in this 3D modeling thing, for a long time, I pushed back and I said, "Nah, this is not for me. I'm just going to go and." I always said I was going to learn on something like Fusion 360.
Right.
I'm glad I did. It was, there's a lot of great educational content out there, and my license was up January 1st or something, like whenever it was up. Or I logged in January 1st as and it was, I had learned my license had expired, and I was like, you know what, this is a good opportunity to go and push myself to learn FreeCAD, and it's been rough, but it is capable for what I need to do. Most of the time I think about, what am I really doing? I'm making enclosures for electronics. I'm printing them on a medium cost 3D printer, FDM 3D printer at that. So.
Yep. What was the driving factor though? Was it because you wanted to save the $500 a year, or was it a philosophical thing that you wanted to go all open source tools?
Yeah, a little bit of both. I mean, so I will say Fusion 360 was the last thing holding me in the Windows ecosystem. So that is why I dual booted my laptop.
Right.
And so now I don't have to do that anymore. Again, that's a personal choice for a lot of people, but now I can literally push that aside and just be like, and from what I hear about Windows 11, I'm not too sad I'm not on Windows 11 right now.
Right.
But I'll still have a Windows machine for when I need it, if I need to get into Fusion or whatever. So
yeah. See, I've got the total opposite. I have nothing that I want to do on Linux, like absolutely nothing. There's nothing driving me towards that platform. People ask me all the time, why don't I use it? It's because there's absolutely no reason to change.
Yeah. I mean, that's I'm not here to debate that stuff. That's for sure. that is some nerdy stuff that we could get into there. And there's lots of other podcasts that do that. So
anyway, we found the Fusion 360 rental thing. Don't you get other stuff? You get Eagle now, don't you? Or you get, some.
Yeah, I think you do get the Fusion Electronics or whatever they're called.
Oh, is it still called Eagle? I haven't even looked in years.
Well, no, I think they forked that product too. So for Eagle's still a thing. I think they're not doing a ton of maintenance on it, but it is still available. Okay. I don't think you can buy it directly anymore.
I think you have to rent it or something, don't you? Yeah, something like that.
Oh, I meant I don't think you can even rent Eagle specifically.
Oh, really? Oh, okay. Yeah, you've got to get the package.
Everything is migrating towards, and it's inspired by Eagle. It's a very similar look and layout and stuff like that, but it's all built into Fusion.
Right.
So,
yeah.
And from an architecture standpoint, it kind of makes sense to do that, right? To have to maintain a different code base and to want them to actually integrate between the two. So I think they want to be able to push stuff back and forth between electrical and mechanical, and so they view it all kind of as an electrical thing in the Fusion ecosystem.
Got it.
So for some people it's a great option. For me, it's I'm out. So
all right. Can we have a follow-up to we've talked about, I'm sure, more than once here on the Amp Hour, and that's Rifa Madness. Reefer
Yeah, we talked about it with
capacitors.
Jeff.
Yes.
at
Oh,
Kaisermas.
yes, yes, we did. And then
Yeah.
somebody who on Twitter Scribble Sun Napkins.
Scribbles on napkins. Yep, scribbles on napkins.
Presumably, these are Rifa, like brand. We were surprised, both of us were surprised to learn that you can still buy Rifa capacitors in the polycarbonate case, right? The old style ones. You still buy them. They still make them, right? So they've got a bag which is marked from 2018, February 2018, right? So these things are only a few years old, and they've got cracks in them, and they've got, these things look 30 years old. Yet he took them out of the bag from 2018. This is incredible. Wow. Why would anyone buy these? Why?
Well, as we talked about with Jeff too, we're surprised they still sell them at all, right?
Yeah,
But,
I'm stunned. Like,
yeah.
But there are some aficionados out there who want the original replacement. Like they don't want. I want to see a Rifa capacitor in there. It needs to look the same. It needs to look vintage. So I guess.
Did we make any jokes about Rifa Madness? I feel like
did,
there's a joke in there somewhere. Yeah, you did? A Rifa Madness? Okay.
Yeah,
great.
I called him Rifa Madness right at the start of this segment.
Great. I did not catch it. It buried itself deep in my subconscious. Sorry.
Anyway, that's another video I've done. What's that, 4 at least?
Got it. That's 5 now. You're at 5. Yeah.
Rifa Madness. Excellent. Woohoo.
Yeah.
Let's go for half a dozen.
Yeah. Oh, I'm sure. Why stop there?
Yeah. Anyway, 2018, and they've already got unbelievable. So it's
I can't get to the photo here. I'm not sure what's the
okay. You can't
problem here.
see it.
Maybe it is a lost tweet.
No, I can still see it. So it shows up for me. But yeah, right. Unbelievable. Like I just. Yeah, done. All right. Don't use them, please. We have to sing happy birthday, do we?
Oh, we do. Yeah. And, not for a 30-year-old either. This is for many years past that.
50.
Yeah. 50 years old to the Signetics.
Yeah.
555. 555 to some.
Happy birthday to you. Oh, and it's by Steve Liebsen, former guest.
Mm-hmm. Yep.
Oh, cool. I didn't notice that. Yep. And Hans Kamenzind as well, former guest.
Not a former guest.
Oh,
former discussion point many times.
Former discussion, yes. Although no, he sponsored the 555. He was involved in the 555 timer contest, wasn't he?
That's right.
That's what I'm thinking of. Yeah. Right.
That is what you're thinking of. Yep.
Yes.
Yep.
All right. Cool. Anyway, 50 years old, is it? I would have thought maybe it was already 50 years old. I would have guessed. Anyway, cool.
Yeah.
Cool bananas. So what was the actual date? So January 10th, 2022. So 72, was it?
Yeah, 72 sounds right.
Yep. Wow.
I think it's more frightening than 1972 is 50 years ago,
Yeah, I know. Because the 70s, like I can remember the 70s. So,
right.
Yeah.
I was not around in the 70s.
No,
but,
you weren't.
But like someone saying that they were like born in the 70s, I'm like, oh, well, that's not.
Yeah, ancient, right?
That's not that long ago, right? No, I'm saying that's not that much older. I mean, like that's not that much older. Like, I have friends that are born in the 70s. So, yeah, like that's not like that long ago. Yeah, right. Exactly. So.
It does not seem, and the 80s definitely, like for some, like new young whippersnappers, the 80s is like something they just see in the movie, the book, what is it? Come on,
the book.
Geez, we're terrible, aren't we?
Well, I don't know what you're talking about. You said there's something they see in the book.
Back
to the Future.
No, yes, well, Back to the Future, and also the
David Jones, folks, no longer just 30.
The virtual reality thing.
Ready Player One is what you're talking about.
Ready Player One. It was on the tip of my tongue.
Oh man,
yep.
Dave's gonna have to hire an assistant just to whisper in his ear.
Just to remember shit.
Yeah.
Right. Yet I can remember
I don't know
vividly.
what this is, but Ready Player One.
Yet I can remember vividly a data sheet I read from 1979. I mean, how is that possible?
Yeah.
I don't know.
Well, the human brain is a marvelous thing,
Maybe I'm just wired for like old school memory, I think.
Yeah, I think actually it's different. Well, it's not really different regions of the brain, but between years. But long term and short term is in different parts of the brain.
Right.
This is not really short term, I guess.
Yep. All right.
You just haven't really anchored on books like Ready Player One or.
Got it.
People.
Yeah, exactly.
Like Bob Weidlar, even though we sell a poster with his image on it.
Right. Do we still sell that?
There's probably a poster somewhere in your lab that's like literally staring at you right now, and you're like, "Oh, what's his name?"
Yeah, exactly.
Yeah.
Unbelievable. It's terrible. Yeah. I don't know what happened to my copy of the poster.
Mine got torn down after when I moved to Chicago.
I've had a couple of moves, and it's just It's been,
posters never make it. You gotta put them in the poster.
Yeah, the poster thing. Yeah, I've got quite a few poster things. It might be down in the bunker somewhere. Sure, it is. Yep. Anyway, 50 years old, 555 timer. Wow. Anyway, we'll link in Steve's thing. He's still writing for the Electronic Engineering Journal. Wow, an actual blog, a real old school blog. That's like, aren't people on like Substack and stuff these days or something? What's the latest fad? I don't know.
Not me, man.
Something like that. Yep. Anyway, I put this one on here because it looks like it actually got the most thumbs up. No, second most thumbs up. Adam Savage, I'm a big fan of Adam Savage, who's just killing it on the YouTubes with his Adam Savage's channel, the Tested channel, which he bought. He's just killing it. He's pumping out so much content. It's incredible. It's fantastic. It's got all new Ghostbusters content and all sorts of stuff. Anyway.
All right. We find out what Dave's really into there.
No, all right. But he did the science of measurement. He talked about how he had a 45-minute video, by the way. He's just sitting in his his workshop. What does he call it? I think he calls it the workshop, I think. And he had an epiphany about the science of measurement, and he's got these gauge blocks, and he's and it's fascinating. He uses these gauge blocks to measure this precise height down to microns and stuff like that. Yeah. And anyway, I think it's a fascinating video. It's definitely worth a watch. What did I post here? It's got 224 thumbs up. I posted on the video. And I put, wait until Adam discovers the concepts of measurement traceability and measurement confidence. It's like he'll be a vault nut before you know it.
Yeah.
So it's just absolutely fascinating. And this science of metrology is fascinating.
Are those blocks? Are they like NIST traceable or anything like that? I actually don't know.
Yeah, they're NIST traceable. They come with a traceable calibration certificate. He didn't mention the word traceable in his video. That's why I mentioned it down before, because he hasn't discovered traceability yet. It's like, but he had this epiphany about these gauge blocks. And it's fascinating. It shows you how they work, and you have to twist them, and you got to put this silicon oil on them. So when you twist them, due to the atomic layers of the atomic structure of the silicon oil, I think it's silicon oil in there, that it gives you a guarantee. So you can stack these blocks, and it gives you a guaranteed like 10 nanometers or something distance between the blocks or something. And it's like, it's really fascinating stuff. I haven't used gauge blocks before, so I'm not a mechanical, guy. But I just found it absolutely fascinating. So, yep.
Yeah, I'm trying to think. I think someone sent me a book about measurement, and it was about like how they used to do measurement for in the machining industries, or maybe it was recommended on here. I'm pretty sure I read it.
Right.
But it was around, especially like in the old days when, I guess there's gauge blocks and stuff like that. But
can we, please, are we able to put a date on the old days? Is it like pre-80s? Is it like...
In my head, it was like the 50s and 60s.
Right, okay.
Yeah.
Right.
But that's a good point. You are pretty old.
Yep. Well, to me, the old days would, like, if I say the old days, I'm probably referring to at least, at most, the 70s. At most, I think. Maybe it depends on what
Yeah.
we're talking about. If we're talking about computers,
Sure,
then I'm talking about 80s. I guess.
Yeah.
But yeah. Anyway, please continue.
It's all relative. It's all relative. Yeah. But no, I can't. I'm searching through my history right now. I can't find it. So
Right.
either I didn't actually. I just knew of it and didn't read it, or it didn't take in the old brain ticker. So one of the two there.
Right. God, look at his workshop and just look at the background. I'm just looking in the background, and he's got pens. He's got this huge box full of. There must be hundreds of pens in there. This guy's incredible.
Adam has done a lot of videos about his storage systems and all that stuff, and
they're just incredible.
I feel like in the shortages of the past 2 years, people that have been kind of pack rats have probably been very smug, and rightfully so. But honestly, when it's like that much storage, I get a little bit stressed out because it's always a mess, and it's always just like I'm not good at like cleaning up.
No, same here. Every time I do a video, every time I do a work on a little project thing or do something here or there, it's just the stuff. Oh, well, I'll fix it up later. I'll do it
exactly.
later,
and
it just never gets done. So
I was following a thread recently where people were talking about like, oh, I actually like to have a smaller space because then everything's within reach, and like in theory, I agree with that in terms of like if you're really moving around
you've got a dedicated function, if you have a lab that has a dedicated function, you're only working on the same type of stuff over and over again, then yes, you want a small lab where you sit there and you rotate on your chair and everything's
like Paul Carlson from Mr. Carlson's lab, like his old lab, I suppose, when he had like all of those scopes in like that narrow little alleyway.
The narrow, the weird looking narrow alleyway.
I got claustrophobic looking at it. Like,
just I was like, watching these videos. I don't know how
you
get claustrophobia.
I mean, like, I love Paul's videos; they're really, really good. But like watching him in there, I was just like, it's gonna fall on him.
Exactly. Yep. It's nuts.
That's not for me, but
no.
Teach their own. I get very. I'm already a pack rat, and it just kind of spreads out like water on the floor.
Right.
So
I set up my lab like that once back when I was a repair tech. Back when I was a repair tech at my first job.
Mm-hmm.
This was in the 80s, but anyway. And
good old days. Is that
the good old days?
The old days.
Yeah, the old days.
Not necessarily. It doesn't have to be good old days, but yeah.
Anyway. Yeah. Sure, anyone who lived through the 70s isn't saying it's the good old days. So
right.
We might be going back there. Just
do you remember?
Saying,
do you remember when a 1N4007 was $10?
Was $10 compared to the $5? Of
course, they're going to design it a 1N4001. It's a quarter the price.
Anyway, just saying that we're going back to the 70s with inflation. Just saying.
Yeah, really,
anyway,
sure.
Yep. In fact, we're already there. Anyway, non-sequitur. Where the hell was I going?
You're saying you had a repair lab as a repair tech.
a lab. I set it up because I was repairing these particular boards, right? So I would set up, my thing so that my chair would rotate, and I had everything there that I needed to actually repair, test, troubleshoot a certain type of boards. And it was great, right?
Yeah, that's awesome.
Yeah.
I feel like it's really only when you get out of a flow and you like, oh, now I have to go and like refactor this entire bench to do something else. Or whatever.
Exactly. Whereas I'm always working on something different because I always say I physically cannot have a lab set up, right? I can't because every video is different. And then I have to move all the equipment to sort of have it in shot, right? To put in shot because I can't just like, there's no one lab layout that's suitable for every type of video I do. It's just impossible. So I'm always moving stuff. Constantly. It's bloody annoying.
Totally. I already talked about Jay Carlson once on this podcast, but I follow a lot of Jay's stuff, including his article about lab organization. He has a very good article about that. I think we talked about last time. But I did follow his advice on the tray setup, the tray system.
And
so that has now arrived, and I have a baker's cart in my lab.
Right.
I do like that it's on wheels, and I do have trays for everything, and everything's labeled, but I'm still learning the ropes in terms of like storage and similarly that sort of thing of, so the idea is you pull the tray out, it's ready to go. Jay also has USB hubs glued to most of those trays as well. So it's like pull it out and it's ready to go. Mine's more like well, I have like long-term storage of parts from upcoming build and stuff like that. So it's like a priority system, that sort of thing.
Right.
But
Cool.
I'll relink in that. Jay's post on that is very good. Very good.
Excellent.
So wheels. I like wheels for everything. That's what I.
Do we have to talk about the Raspberry Pi again?
We don't have to.
No, but I just thought it's interesting. Blog post from Eben Upton on the 17th of January. Then now you can buy the RP2040, which is their Raspberry Pi Micro. It's their custom.
That's right.
Sort
That's
of,
right. So
even though it's an ARM core.
Cortex
right?
M0 Plus with 140, 150 megahertz. It's pretty beefy for what it is for the cost. So.
Yeah. Anyway, they got so many requests for just the chip on its own that they now sell them by the reel. So you can buy a reel of 500 of them at a unit price of 80 cents, or you can buy a reel of 3,400 for 70 cents. Yeah, because they had people actually requesting tens of thousands of chips, right?
Yeah.
So I don't who's using these? Who's actually, is it competitors making Raspberry Pi clones? Is it what? I don't know.
Well, this is an embedded device, so this is not
right. Okay.
Yeah, so this is we had the team on the show.
Yeah, but it's used on one of the new Raspberry Pis, isn't it? Which bloody I don't keep up. No.
Well, yes, technically, yes, it is a Raspberry Pi board. It's called the Pico, but there's not much on there.
Oh, it's the Pico, right? Yes.
Yeah,
right,
so
okay.
that's the Pico, and
got it.
Yeah, so you're seeing these stuff. So like, there's a Circuit Python port for it. There's an Arduino port for it. There's I think you can just write C on it.
So, I know who ordered a reel of 10,000 from them. Adafruit, guaranteed.
Yeah, of course.
Yeah, because they're probably chewing out boards.
Yeah, they got a bunch. I think they got some of the early ones. So like SparkFun, Adafruit, they definitely have some boards based on it.
Got it.
There's two things that's not novel here. One is the PIO system. So that's got like kind of quasi-programmable, like kind of side processing, not quite programmable logic, but it can do like a function. It's kind of like a serial engine that you write code for in order to process incoming digital data. So that's very interesting at this price level for sure.
Yeah, right.
But the other novel thing about this part is that you can buy it.
Yeah, they've actually got stock. Or do they? They say down the bottom, unobtainium no longer.
Yeah.
It's built on a modern semiconductor process for those playing along at home. It's the TSMC 40LP. But then I'm wondering, how do they get fab time at the largest fab maker in the world?
I think these have been built a while ago. I think.
Right. Right. But, as a result, it makes extremely efficient use of scarce silicon wafer supply. Each die occupies just 2 square millimeters. Very interesting. And each 300 millimeter wafer yields roughly 21,000 dice. Not die, because they're called dice at that stage.
Okay.
Yeah.
That's pretty par for the course as far as I can tell.
They actually, it is. They actually tell you they have sufficient wafer stock on hand to produce 20 million chips. Interesting. There you go. So they must have done a run just before the real supply crisis hit, because I'm sure that all the bigger manufacturers would have bumped, or TSMC would have bumped, who's this Raspberry Pi business? I'm sure they would have got bumped for Apple or, TI or somebody else, They would.
Yeah, I'd love to hear how that works on the chip side, because so I had a friend who talked to me a couple weeks ago. He's like, yeah, all of my parts, they just added 52 weeks to all of my parts.
Yeah. Somebody posted that. I can't remember
terrible.
on Twitter. Somebody posted a genuine date of like 2050 or something. 2050 was the date that popped up on DigiKey or something. I mean, come on. They're taking the piss now. I mean,
that's they're just like, screw you. We do not want to sell you parts. That's an effective no bid.
Right.
Effective no bid.
Yeah, exactly. Unbelievable.
I feel for it's
it's totally
terrible
shit.
right now.
Imagine if you built your entire business around this one product and you couldn't change a part or whatever, and and you just got, and due to timing, you just got caught in the middle of all this. And yeah, you just can't buy the part, and you built, your whole business, some startup business around it, put all your money into it or something. And then, it all went tits up. Wow.
Yeah.
That'd be, it's happened to many.
So my heart goes out to all of you that are dealing with this right now. We've obviously been talking about it a lot on here. Yeah. It's not going to stop for a little while. I feel real bad about it.
We'll still be talking about it in 2023. That's my prediction.
Yeah.
Yep. We'll still be talking about.
I'm hoping we'll say things like, it's starting to get better.
It's starting to get better, right?
Maybe we should have a code word for it on here. Every time we're going to talk about it.
Some sort of safe word.
It's a safe word. Yeah.
It might trigger people, so we can have like a safe word before we mention the component crisis, just to prevent people from going, oh no.
Bubblegum tap shoes.
Right. But considering that we haven't been able to remember 3 key industry figures in this episode, exactly. I don't think
next time we record, I'm going to be like, bubblegum tap shoes, and it's just going to be 4 minutes of silence as we're both like,
right.
Why did we say that again?
You're going to put a sticker on the top of your monitor, bubblegum tap shoes.
Right.
And the wife's going to come in and go, what?
Yeah, what does this mean?
Yep. Oh, boy. All right. Oh no, our hour's up. But I want to give a shout out. I want to give a YouTube shout out, please.
Sure, go for it.
To Kathy Loves Physics and History channel. This one blew up. This channel blew up. Anyway, the secret history of electricity, and she's got, I don't know, a couple of dozen videos at least. 2 or 3 dozen videos on the secret history of electricity. We're talking like Maxwell, we're talking Wheatstone, we're talking Joule, we're talking Ohm, we're talking, like all of the famous names, right? Is there Kirchhoff, there's Heisenberg in there, there's Planck, there's Coulomb. Sorry?
Heaviside?
Oh, don't know. Rutherford. Anyway, she's done like great history of electricity videos, and she was like getting only a couple hundred views per day or something, like before a couple of weeks ago, and then all of a sudden she's bigger than she was getting 2 million views a day. Like it's I gave her a shout out, but I don't think I was the cause of it. I noticed it very early that the algorithm, suddenly the magic algorithm just started pushing her videos to me, and I started watching them going, holy shit, I've never heard of these. These are great. And overnight, the algorithm has just pushed her into stardom. So I highly recommend you go subscribe to Kathy and watch her videos because they're just great. The history of the Wheatstone Bridge and, like fantastic stuff.
Yeah.
Like, Edison versus Tesla, why they invented 3-phase electricity, the history of 3-phase and stuff. Well, there's the history of 2-phase for you polyphase fanboys, by the way.
Right.
And like, I had no idea that this content existed, and the algorithm has bestowed upon her the light, the shining light of an audience, and it's great. Yeah, so hats off to her. They're fantastic content. So
I'll have to dig into those.
Yep.
Dig in.
They're absolutely terrific. So and they're all on content. They're all for us. There's a few physics ones in there that are more into those who are into physics kind of things, but. No,
Killer.
All of if you've got a favorite one, if you've got a favorite from history, she's probably done a video on it. If not, I'm sure she takes suggestions. So, yep. Kathy Loves Physics and History. Go check it out. Link below. Right.
All right.
Is that
I think that's it, man. I think so. We'll be back next week talking about bubblegum and tap shoes.
Yeah. Right. Catch you next time.